Welcome to this platform. So in this video, we are going to cover sets, and it being the first lesson, we are going to look at sets paper 1. We are going to focus on what comes in paper 1, and then part 2 will come where we are going to cover what comes in paper 2. Alright, so to start, we are going to define what a set is. So a set is just a collection of well-defined objects. So a set is a collection of well-defined objects. That is what we call a set. So for example, we can have a set of let's say fruits. Okay, a set of fruits. So which means in this set we are going to find fruits. Let's say oranges. We can put mangoes. We can put apples in the same set. We can have grapes. Okay, so this is specifically the set for fruits. So that is the reason why we're saying a set is just a collection of well-defined objects. We cannot have a set, let's say a set of plates and shoes in one. It has to be well defined. All right, so after looking at this, I think what is important is to look at the set notations. What are the notations that we are going to use for a set? What are the notations that we are going to use? So for a set is named, we use a capital letter to name a set. And of course, these brackets, which are curly brackets. And of course, what you find in a set are called elements. For example, you have this set containing 1, 2, 3. So these are called elements. And of course, this is the curly bracket. So it's the one that you use specifically for sets. And of course, elements are separated by commas. I think that's something you should know. All right, so about the notation is that sets are named using a capital letter. And of course, sets, you put them in the curly brackets. And of course, what you find in the sets are called elements, and they're separated by commas. I think this is simple to understand. All right, so you're not going to use brackets of any sort, but use curly brackets. All right, after this part, we can look at set operations. What are some of the set operations that we can discuss here? So one of the set operation that we can discuss here is this operation, of which this one represent element that belong to the set. So if the element belong to the set, you use this one. All right, then of course the second one, so this one we are going to put at as first one. Then of course the second one we can put the subset. So subset like this. This is the subset. What about the subset? If you have a set, let's say set A, we say is a subset of B. What does it mean? If set A is a subset of B, it means that all elements of set A belong to set B. In other words, set A is found in set B. Okay, so that is what it means. Then of course, a set, you should know that a set can be, a set is, let me just say, is a subset. So a set is a subset of itself. Very important to understand. A set is a subset of itself. This is the second operation that we can look at. The third, let us look at the empty set. So for the empty set, what do we use to denote the empty set? So you can represent the empty set like this. or just using brackets but with nothing inside. For example, if set A is empty set, we just put this, or you can just put the brackets like that. All right, let us look at the fourth operation that we can look at. And you need to pay attention because as we go on, we start working on this. So the other operation that we can look at is number of elements represented by n. So this represents number of elements in a set. Okay, in a set. For example, if you have a set, let me put Q. If set Q has the element A, B, C, D, E. Okay, what is the number of element of set Q? So you denote it like this: number of element of set Q. Count them: 1, 2, 3, 4, 5. So set Q has 5 elements. So that's something that you need to know. Then the fourth one, or the fifth one, we can look at the universal set. So E, you can use E to represent universal set, or U. So n of these you can use to represent the universal set. What is the universal set? So for the universal set is a set that contains, okay, the set that contains all the elements, okay, all the elements in a, so it contains all the element in a certain context. What does it mean? So when you are discussing, if you are discussing, you have set A, B, in other words, the whole, it contains all the elements, okay, more like the mother of all sets. So that is where other sets are made. So that is what we call the universal set. Okay, so let us look at the number 6. So for the number 6, we look at the intersection set. So intersection set denoted as such. This one is what just common between the sets or among the sets. Okay, so gives the elements. So this one can say gives the elements common between the sets. So it gives the elements common between the sets. That is what we call the intersection sets. It can be 2 or more sets. Okay, as we are going to look at these even as we go on. Okay, so at a moment know that an intersection set gives what is common between or among the sets. Then we can look at the number 7, which is the union set. Okay, union set. So as you know, union is to join. So for the union set, contain all elements of both sets. Okay, so contain elements of both sets. That is what we call union. So contain elements of both sets, or join sets. So if you have 2 sets, they ask you of the union, you just join them. And we are going to see how that works. Finally, the other operation, the other one that we can look at is the complement. So complement, what about the complement? So for example, let me say set A complement. What does it mean, set A complement? So it means a complement set contains all the elements, that is, or let me say except this set, or exclude set A. Everything that is in the universal set, that is a complement. So in other words, a complement of a set contains all elements of the universal set except that set under discussion. In this case, the set under discussion is set A. So if you had element of set A and what is in the universal set, when listing A complement, we are not going to include what is found in A. Alright, so that is what we are going to do. Let us actualize what we've just, or let us look at how we can apply what we've just from learning. So let us have the universal set. Okay, let us have the universal set, and for the universal set, I'm going to say natural numbers less than 11. Okay, that is set universal set, or that is the universal set. Natural numbers less than what? Less than 11. Now there's another thing here that you need to know. You need to know something about natural numbers. How are we going to list this set E in terms of putting the elements here, which are numbers? So natural numbers are counting numbers, okay? They are counting or positive whole numbers starting from 1. Since we are saying less than 11, so we are going to list them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are saying less than 11. So in other words, this is the universal set. So this is very important to understand these numbers. So natural numbers are just counting numbers or counting positive numbers starting from 1. So when you're talking of natural numbers less than 11, we are looking at ending up to 10. So 1 up to 10. These are less than 11. But take note, they are counting number or positive whole numbers. All right. Now, let us say set A is given as 2, 3, 5, then of course 7. That is our A. Then our set B, let us say set B is given as 1, 2, 3, and of course 10. Let us have another set, which is set C. This time around, set C start from 5, or let me start from 3, 4, 5, 6. Okay, let us have this one as set C. Now, with what we've learned, let us say now they ask us to list A union, or let me start with A, A intersection B. List, let's say the question is list A intersection B. Okay, what is the set A intersection B? So where we are coming from, we know that intersection is what is common between the sets. So in this case, the set under discussion, or the sets under discussion, is A and B. What is common in A and B? So we are going to go where there's A. So this is set A and this is set B. And let us find now what is common. So if you look at this, there's 2, there's 2, there's 3, there's 3. Is there anything else? No. So the common elements in these two sets is 2 and 3. So this is the set A intersection B. What about if we were to list the set A intersection C? So A intersection C, we are still looking at what is common between A and C. Now, the set that you are able to see right here, this is the set C, and this is set A. What do they have in common? So if you look at them, the 3 is common and here is common. The 5 is common and there is common. I mean, the 5 is common in both. Anything else? I guess nothing else. So the intersection of A and C is 3, 5. And this is the intersection. All right? This is simple. This is simple. So that is how you look at intersection. So intersection is just what is the common in the sets. All right, we advance further. This time around we say list A complement intersection B. Okay, A complement intersection B. How are we going to list this set? How are we going to list this set? So now, to list this set, we need to know A complement. Okay, we need to know these sets individually. So let me just remove this. I guess we have no use of it. Okay, so for C, we need it. But let me just create some space here. So now we are going to first list these sets individually, A complement, before we find what is common. So A complement, we said, is everything outside A. So which means from the universal set, A is this set. Now the universal set. So we are not going to include 2 in the complement of A. We are not going to include 3. We are not going to include 5. And of course 6. Whatever remains, that is A complement. So A complement, you just see, you can choose to hide that set. Okay? So exclude the element in A, but everything that is in the universal set. So in other words, 1, 4, 7, 8, 9, 10. So this is A complement. Okay? Then now, we find what is common between A complement and B. Here is set B, and here is the A complement. What is common in these two sets? Do we have anything common? You find that there's 10. There's 10 there. Anything else? There's 1. There's 1 there. I can only see these 2. So please, in the case I've missed 1, okay, you'll be able to tell. So A complement intersection B is just 1 and 10. I guess we all I guess we are together at this point. So that is how you find A intersection B complement. All right, this is a set. I guess you've picked something and you've written something, so I can remove this. Okay, I'll keep on using this. All right, let us have, this time around, let us have B intersection C, then in brackets complement. What about if you are given such a situation? What do you do? So in this case, to make it easy, or to make your life easy, just look at what is inside. What is inside is A intersection what? Intersection C. B intersection C. So you can start by listing this set inside B intersection C. What is the set? What is common between B and C? What is common between B and C is 3. What else? Is that 3? No 4, no 5, no 6. I guess it's just 3. So remove this set. We don't need it. Okay? So that is what it means. So A intersection complement. That set A intersection B complement, remove it. But whatever is found in the universal set. Okay? So this is the 3 here. So now B intersection C complement is going to be the set outside A intersection B, and therefore we are going to have 1, 2, 4, 5, 6, 7, 8, 9, 10. So we've just removed 3 from the set. So that is B intersection C complement. I guess we are together up to this point. Okay? things are getting sweet soon. We'll begin to see some complex operations to perform here. All right, let us proceed and look at union. What about if you have A union B? So that was it about intersection. I guess you've learned something. What about A union B? So union, we said you join two sets. So we are going to join A and D, or list the element in A and B. But of course, you need to list them in order, starting with the smallest one. So if you can see A, the first one is 2. While in B, the first one is 1. So the first one is 1. In A, there's 2, and in B, there's 2. You just put it once. And of course, going to 3. Is there 4? No, in both cases, there's no 4. So the next number is 5. Then, of course, 7. And of course, finally, 10. This is A union B. So we've just joined, we've just combined the elements in A and B. That is A union B. I guess there's no confusion. Let us have a look at B union C. What about B union C? So we just joined what is in B and what is in C. The smallest number here into these two sets is 1, followed by 2. There's a 3, there's a 4, there's a 5, there's a 6, and of course there's a 10. Okay? So you've just joined B and C. So that is the B union C. What about A complement union B? What about A complement union B? Now, you know that A complement is everything outside A. So A complement, everything outside A, or everything or excluding A. So in the case we said 2 is not going to be, so 2 is not going to be part, 3 is not going to be part, 5 is not going to be part, 7 is not going to be part, because all these are found in A. But whatever remains in the universal set, that is 1, that is 4, that is 6, 8, 9, 10. That is A complement. So A complement union B. So this A complement, we join it with the B. Now set B, as you can see, is 1, 2, 3, 10. So joining it with A complement, the lowest number is 1, followed by 2, followed by 3. There's a 4 in A complement, then there's a 6, next one is 8, 9, 10. This is the A complement union B. I guess you've gotten that. So this is where paper 1 start from. So you're going to find the sets that you're going to list just like this. So you have to be very careful. So one of the number system that I've mentioned is natural numbers. But of course, as we go on, we are going to discuss some more. All right. What about if it was A union B, list the set A union B complement. So you just look at the set A union B and remove it from the universal set, because A union B complement, which means excluding that set A union B. So whatever is in this set in relation to the universal set, in short, these elements in A union B should not appear in the complement. So now what are we going to have? So we have 1 here, so 1 is not going to be part. We have 2, we have 3, we have 5, we have 7, we have 10. So whatever remains, that is a complement of this set. Now what remains there, if we're able to see clearly? So if you were to look at this, 1, 2, 3, only 4, 6, 8. Okay, so we have 4, 6, 8, 9. 8, 9. That is the A union B complement. I guess you've gotten that, or I guess you've gotten a thing here. So that is it about union. Let us have a look at another one. which is okay. I think we have performed the complement. The remaining part is now to look at, let's say, about 3 sets. Let's say you are told to list a set A complement intersection B union C. How do you list this set? So this set, normally to list it, if you look at it, it looks complicated. But the strategy that you're going to apply is that you're going to break this one in 2 parts. So you can start by listing A complement first. So list A complement first. And A complement, we said everything outside the set A, but of course found in the universal set. What's that? So set A, as you can see, is right here. So everything not found in A, but in the universal set. So our set is not going to have a 2. It's not going to have a 3. So it's just starting with the 1, no 2, no 3. So goes to 4. No 5 goes to 6. No 7, so 8. Then 9. And of course 10. So this is the set A complement. Okay, let us confirm. 2 is part of this. 3 is part. 5 is part. And 7 is part. So we are going to remain with 1, 4, 6, 8, 9. Okay, do we have a 10? Yes, also a 10. So we've listed the A complement. Now, our next target is to deal with these in brackets. That is B union C. So we can find the set B union C. How can you find the B union C? Just by joining B and C. The lowest number in these two is 1, followed by 2, followed by 3, followed by 4, followed by 5, followed by 6, then of course 10. I guess this is A union C. So 1, 2, 3, 4, 5, 6, 10. Okay. Now, after we've listed these, we are going to find what is common, and that is A complement intersection B union C. Okay, what is the set? So what is common in these? What is common? So if you look at these two sets, there's 1, there's what else? 4, there's 4. There is 6, there is 6. There is 10, there is 10. So the set is 1, 4, 6, and 10. So this is what we have as A complement intersection B union C. Now, listing these sets is very important as we are going to start looking at shading. So the way you list these sets, that is what you are going to do as we start shading. It will be very easy. So if you know how to list these, at this particular point, if you understand, which means we are good to go. Let us list one more set. Let us list one more set. So this time around, let us have this set. So you're saying list A union B intersection C complement. Okay. So like I said, you break it in parts. So the first part, we are going to list A. So set A. This is not A complement, just set A. And we already have it. So set A is just 2, 3, 5, 7. That is set A. Then B intersection C complement. Let us list it. Now B intersection C complement is just what is common. We can start by finding B intersection C normally. B intersection C just normally. What is the common between B and C? So what is common between B and C? You find that it's just the 3. Nothing else. Just the 3. So now, after finding the intersection, we are going to say this we are going to exclude it in B intersection C complement. So everything in the universal set, but except 3. So we are going to have 1, 2, 4, 5, 6, 7, 8, 9, then of course 10. Okay, that is the B intersection C complement. Now, we have the two sets now. We can join them. We can list the set A union B intersection C complement. Okay, so we join these. 1. We have 1 in this set, that is for B intersection C complement. We have a 2. We have a 3 in A. We have a 4. We have a 5. We have a 6. We have a 7. We have 8. We have 9. We have 10. So we find that it is the universal set. Okay, so we found that it's a universal set actually because we've just listed everything. I guess we've done the correct thing, but that is how we basically list the sets. All right, let us shift our attention to shading the sets. How do you shade a set? Shading the sets. Now, before we go to shading the sets, I think there's something that I need to mention here that you need to understand even as you go as you prepare for paper 1. Okay, as you prepare for paper 1, before we go to shading sets, the other thing that I will mention is sometimes you're going to find that a set is given as a set of natural numbers. So it's very important for us to know natural numbers. So natural numbers are just counting numbers, positive counting numbers from 1 up to wherever you're going to end, that is infinity. Which means you can continue counting 1, 2, 3, 4, 5, 6, 7, 8. Those are natural numbers. They are counting positive numbers. Whole numbers, of course, not decimals. Then, of course, we have also the other number that we have, which called the whole numbers. Okay? So on the natural numbers, if we are to list the numbers, let's say a set of natural numbers, if we are to list the set of natural numbers that is less than 10, is 1, 2, 3, 4, 5, 6, 7, 8, up to 9. That is less than 10. But for all numbers, they are natural numbers, but including the 0. So natural numbers are counting numbers as well, but include the 0. In other words, if you have the whole numbers, a set of whole numbers, the numbers start from 0, 1, 2, 3, 4, 5, 6, let's say less than 10, 7, 8, 9. These are all numbers less than 10. So the only difference between the natural numbers and the whole number is that the whole numbers start with a 0, but of course the natural numbers start with a 1. So very important to understand these even as you prepare for paper 1. Then the other one that we can look at is even numbers. Even numbers. So if a set is given as even numbers, of course they will give you, let's say, even numbers less than 10. Okay? So a set of even numbers less than 10. Even numbers are just numbers that are divisible by 2, or that can, in which there are all numbers in which 2 can go. Okay? So those that are divisible by 2. And of course, starting with a 2, 4, 6, 8. We are saying less than 10. So these are even numbers. Okay? The other one that we can look at, the number that we can look at are odd numbers. Okay? Odd numbers. What are odd numbers? So for odd numbers, we're just looking at the numbers not divisible by 2. Okay? So if you have a set of odd numbers less than 10, the ones that are not divisible by 2, we start with 1, 3, 5, 7, and of course we are going to less than 10. So these are odd numbers. So 1, 3, 5, 7, odd numbers less than 10. So those that are not divisible by 2 are odd numbers. Then of course we have also this kind of numbers of which the examiners like this one, prime numbers. Prime numbers. So prime numbers are numbers greater than 1 and cannot be divided by any number except 1 and itself. So numbers greater than 1 and are divided by 1 and itself. So are only divisible by 1 and itself. Okay, so let's say even numbers less than 10. So you're saying greater than 1. So for example, 2. 2 can be divided by 1 and of course itself. Then 3. Then we have 5. Then we have 7. 9 is not a prime number because it can be divided by 1, 3 and of course itself. But those that are divisible only by 1 and itself are what we call prime numbers. So having learnt about prime numbers, we can now shift our attention to shading the sets. How do we shade the sets? Okay, so let us look at now shading the sets. So how do you shade the set? Let's say you are given shade A complement intersection B union C. Let's say this is what you are given to shade. So when you are given such a question, and of course the Venn diagram will always be given, you have 3 sets here. So these 3 sets, they are put in the universal set, okay, represented by the circles like this. That is what you're going to find. You are just asked to shade. Let's say these sets are named A, B, and C. Then they are saying shade that set that you're given on top. What is the strategy that you're going to use? So for this one, you are going to come up with a universal set of numbers ranging from what? From 1, 2, 3, 4, 5, 6, 7, just up to 8. And of course, you're going to put these numbers in the spaces 1, 2, 3, 4, 5, 6, 7, and of course this one here. So all the spaces at least put one number. Okay, all the spaces put one number. If you want, you can use letters, 8 of them, A up to, I don't know, up to where you have 8 letters. And of course these numbers, please, it's not that you can put just in this order, but whichever order that you put them, you should be able to find, you should be able to shade the set successively. So use this to come up with numbers just with like a pencil, so that at the end you can even remove them or even leave them. So now after doing this, you are going to list the sets that you are given. So the first set to list is A complement, and of course A complement, you are just simply going to list everything outside set A. Now set A is everything that you are able to see here. This is set A. The whole of this one is set A. Okay, the whole of that one is set A. So everything outside set A is what we are going to list. So there's 3, there's 6, there's 7, and of course there's 8. This is what is outside A. Remember the complement of a set, except that set, but of course everything outside, including what is in the universal set. So exclude that set, but everything in the universal set. So that is A complement. Then you are going to list the B union C. Now B union C, you are just going to join everything in A and D. I mean everything in B and C. Okay, you are going to list everything in B and C. Now B and C, first B is the whole of this one, then of course C is the whole of this one. So everything in this set that is in blue and of course green, you list them. So you have 2, you have 3, you have 4. Let me just try to bring it down here. So B union C. So here what you have 2, you have 3, you have 4, you have 5, you have 6, you have 7. That is it. Okay, that is B union C. Then now you find what is common in these two. Is it what is common? What is the set that you are shading? Yes, you find the complement, the intersection. So you list the set now: A complement intersection B union C, which is something that we've just done where we're coming from. So now what is common between these two sets? So you find here there's a 3, here there's a 3, here there's a 6, here there's a 6, there's a 7, there's a 7, but in this case there's no 8. So the sets that are common here is 3. The elements that are common is 3, 6, and 7. Then what are you going to do? You have your set. So you are going to shade in the part you are going to shade in the part where 3 is, where 6 is, and where 7 is. So where is 3? 3 is here. Where is 6? So you're going to extend it where there's 6. And of course, even where there's 7, like that. So this is the part that you need to shade. That is how you simply shade the set. So that is it. That is it. Okay? And you can see from here, A complement. A is not shaded at all. But B union C is the one that is shaded. So you shade for the wanted region. That is something also you need to know. We shade the wanted region. Very important. Let us look at one more question. Shade A union B intersection C. Okay, B complement. Let me put this time around B complement union A intersection B. Okay, now the same strategy applies. So let us come up with the Venn diagram and of course these sets inside. So this is the universal set, and of course we have the sets inside. Let's just draw them a little bit bigger. Okay, like that. So we have the set. This is A, this is B, this is C. We come up with numbers 1, 2, 3, 4, 5, 6, 7, 8. Okay, then we put them 1, 2, 3, 4, 5, 6, 7, 8. Then we list the set. We start with B complement. So B complement is everything outside B. So the set B is everything outside B. If we are to look at B, B is the whole of this one. So if we are to close B, everything outside B, we are going to have 1. Everything outside B, we only have 1, 4, 7, 1, 4, 7, and 8. That is everything outside B. Then we list A intersection B. What is our A intersection B? So the intersection of A and B. The intersection of A and B is what is common in A and B, and normally at the middle. So this is the intersection section here. Okay, so this middle part is the intersection. So you only have 2 and 5. Okay, then now you find what is the common. So the intersection, we are saying we have what? B complement is everything outside B. Okay, then of course is it giving us the empty set? B complement, everything outside B. Okay, 1, 4, 7, and 8. Then intersection B. Okay, so it is giving us empty set. Let me just change the operation because these are made up questions. So let me put union. So A union B, we are going to find everything that is in A. Let me say A union C. A union C, we are going to find everything in A and in C. And you have 2, 3, 5, 6, there's 4. 4, A and C. A and C, A and C we have 1, 2, not 3, but 4, because A and C is this, and of course this. Okay, so we have, this is 6, please. So we have 1, 2, 4, 5, 6, 7, not 8. So this is A and C. So 1, 2, 4, 5, 6, 7. Now, having listed this set, the final part is to list the set now. B complement, what is that? Union. Then in the bracket, I've changed to A union C. So let us list this set. So we're just going to join the two sets. So we have 1, we have 2, we have 1, 2, 4, 5, 6, 7, okay, 8. Is it 8? Yeah, it's crazy. We'll see how it come out. So this is where we are going to shade, where there are these numbers. So which means even here, we are going to shade. Outside here, we are going to shade because that is where 8 is in the universal set. Then now, where else are we going to shade? Where there's 1. So where there's 1, we are going to shade as well. Where there's 2, we are going to shade. Where there's 4, we are going to shade. Where there's 5, we are going to shade. Where there's 6, we are going to shade. Where there's 8, 7, we are going to shade. Where there's I think only where there's 3 is the part that remains. Okay, if I'm not mistaken. So that is how we can shade the set. I guess you've gotten something. Given the question, will you be able to try it out? So let us say you are going to list, to shade, not to list, shade the sets. So here are the sets that you are going to shade. Okay, A intersection B union C complement. Then A complement union B intersection C. Okay, let me say A union B intersection C complement, something like this. So these two sets, try them out and see if you understand. Otherwise, we can end here. And of course, if you find challenges when it comes to answering paper 2 questions, paper 1 questions, kindly bring it on. The only part that is remaining is where you need to write the operation given the already shaded part. If you understand this part, that part should be easy to handle. Otherwise, if there are some challenges, it's the part that we can tackle in the next one. We can end here, please. If you are interested in the lessons, online physical lessons, let's say first physical lessons, we are found in Kabwata, just near Kabwata Primary School, along 8th Street. That is just right at Chipindani. So if you are interested, you can get in touch on the number 0976, that is 402563. But if you want to register online for mathematics, physics, chemistry, and biology, You can still get in touch on the same number, and of course for that I charge just 100 kwacha per subject. And of course science is not calculated as science, but of course you consider physics separately, chemistry separately, which means science is 200 per month. But these other subjects such as biology is 100 kwacha, mathematics 100 kwacha per month. Would you be interested to join us? Get in touch. Otherwise we can end here, and of course see you in the next one.